This is a counting puzzle. We see we have a rectangle that is 3 by 5, and we're asked to find out how many rectangles are in the problem. This sort of problem, it really helps to be organized, to have a system so that you know everything that you've been counting and you don't miss stuff or you don't duplicate, or at least if you do miss stuff or duplicate, your organizational scheme will reveal that. So I'm going to try to fit it all on this one little screen that I have, but bear with me while we work it out, and we will keep totals, and if I have to erase along the way, we'll just keep totals off to the side. So the first thing I want to do is find all rectangles of this size. And I see I have 1, 2, 3, 4, 5 times 1, 2, 3. I have 15 of them. And then I have a rectangle that's like this, 2 rectangles across. Now I have to think about overlaps while I'm doing this. So there's one, there's another, there's another, there's another. So I have 1, 2, 3, 4 for each row, and I have 3 rows, so there are 12 there. I should put this here. And following in this vein, I want to know how many rectangles like this that are 3 long are in this puzzle. So if I think here's 1, there's 2, there's 3 in one row, and there are 3 rows, so there are 9. What about 4 in a row? Well, I see 1, 2, 3, 4. So there's 1, and then I bump over, and there's another one, and there's 2. 2 per row times 3 rows. 2 times 3 is 6. And then I want to talk about 5 in a row. And we see that there's 1 per row, so there's 3. And that's as far as we can go for stacking the small rectangles horizontally. Now let's look for 2 like this. And I see I have 1 here and 1 there, 2 per column times 5 columns, so I have 10. And then I went 3, so I have 1 per column, and there are 5 columns, so I have 5. And that's as big as I can get in stacking them vertically. The next shape I want to think about is 2 by 2. And I see I have 1 here, 1, 2, see 1, 2, 3, 4, and then I bump down 1, 2, 3, 4, so that gives me 8 of those. Now what about 3 this way and 6? So I see I have 1, 2, 3, 4, 5, 6. So I have 6 of those. And then I went 4 across. So basically a 4 by 2. So I have 1, 2, 3, 4. So I have 4 of those. And then we have a 5 by 2. And so I have 1 and 2. If I'm going vertically now, I want to know how many 2 by 3s there are. So I have 1, 2, 3, 4 of them. I can't get any taller than that, and I've already done the 2x2s, so it's like an extension. Extending this 2x2 into this one is the same as extending this 2x2 into that one, with the idea of a row or column going to 3. The next shape I want is a 3x3. So I have 1 there, 2 there, 3 there, and that's as big as that's going to go. Now let's do 3 this way and 4 this way. So there's 1, and then I skip over and I say there's 2 of them. And I can't go up by 4, I'm limited there. So the last one I want to do is the whole thing, which is 5x3, and I know there's 1 of them. Now that I've gone through and systematically counted or organized them so that I know that I haven't skipped any shapes, and if I'm not 100% sure that I haven't skipped any shapes, I can go through and think about what it is that I've done. In this nice systematic way, can I expand this one up any higher? No. Could I expand this one to the right? Yes, I did that there. Can I expand this one higher? No. Can I go to the right? Yes, this one's there. And that's the full size, so I can't get any bigger than that. At this point, what I need to do is total them all up. So 4 and 3 is 7, and 3 more is 10. So I have done these, and I like putting little marks by them to know that I've counted them. 15 and 12 is 27, and 9 is 36, and 6 is 42, and 3 is 45. 10 and 5 is 15, and 8 is 23, and 6 is 29, 33, 34, 35. And so what I get is, there's a 10, carry the 1, 4, 5, 8, 9, 90 rectangles in the whole thing. 90, which is surprising for such a little guy. But you have to think about what that means, and you have to be systematic and look at every possibility.